Class, welcome back. Here we go. We are moving away from domain and range for a little bit here, and we're moving on to even, odd, or neither functions. Okay? So what I'm going to do is I'm going to draw a couple of graphs that have to do with even functions and odd functions. Okay? So something like this. Alright, there's one even function. I can even do something like this. Okay, so what I want you to kind of keep in mind here, well, this is probably some sort of x squared, right? Then there could be more. This might be a x to the fourth, dot, dot, dot. There's extra stuff. But what I'm trying to have you guys see here is that there's an even exponent, okay? So the first thing that we need to recognize, even functions, they'll start with an even exponent. However, that is not the only test. So get that out of your mind right now. Okay, it helps. It's something to start with, but if you're shifted left or right, then it's not even. And the reason is because, what do we notice about these two graphs that I drew? Hopefully you just said that they have y-axis symmetry. Okay, so in order for a graph to be an even function, there has to be y-axis symmetry. So now that is a test that you can use to determine if a function is even or not. Just be very careful. I mean, things can be moved to the left, right, even just a tiny little bit, and what happens? That throws it off completely. So we're going to get into algebraically, and that's going to be a better bet for figuring out if something is even or not. Now, if we look at an odd function, well, what did I say here? This was like x squared, this is x to the fourth. So how about I do something like y equals x cubed, right? And then there's extras, there can be all sorts of different stuff. But we know that an x cubed graph looks something like this, all right? Not the best, but okay. Another x cubed, right? We could have something like this. Maybe go up, past, and then through, and then comes back. Okay, so what do we notice about the two graphs that I made? Well, a couple of different tests, right? We know that if we kind of spin the paper, right? If I spin this paper around, they look identical, right? This looks the exact same as this. So what happened? This was rotated 180 degrees. And do you remember what we say about something when it's rotated 180 degrees? What type of, excuse me, what type of symmetry? O, odd, O, origin. All right, so even functions over here are always going to have y-axis symmetry. Odd functions, if a function is odd, they're always going to have origin symmetry. However, again, these could be off just the slightest little bit, right? This maximum might be a little bit different, right? The y value might be a little different than the y value of the minimum, and what happens? And it's wrong. Or it's not wrong. It's just not an odd function. So what we do is we do better tests. We can do better. And what we say we're going to do is we're always going to calculate f of negative x. That should sound familiar to you from when we talked about symmetry, right? We said that if I had a point at x comma y, well, that when I plugged in negative x, I should have a point at negative x comma y. All right, so we're kind of doing the same thing here. We're just going to actually do it with algebra. What did we say about odd functions? We said that if we had a point x comma y, then we should have a point at negative x, negative y. All right, so what happened? What are we seeing here? If a function is even, then when we put in an input of x, or if we put in the input of negative x, I should actually say, we're supposed to get the same exact output. So what we say is we plug in, we calculate f of negative x, we do a bunch of algebra, right? There's going to be a bunch of steps. And what happens? Well, I should get the same y value, or in this case, I'll call it f of x. Alright, so when I plug in negative x, I still get out f of x, the same original function. Alright, so let's put that in words. Plug in negative x, get the same function. Alright? Okay, well, what happens now? Hopefully you guys can even just draw the connection from this idea. Maybe you could do this section on your own. So now we know that a function is odd when, again, f of negative x, I do a bunch of algebra, but now this time what happens? When I plug in negative x, I'm supposed to get negative y, or in this case, I'm not going to use y's, I'm going to use f of x, so negative f of x. So in this case, what's happening? I'm still plugging in negative x, right? The tests don't change. I still plug in negative x, but now I get the opposite of the function. Okay, the opposite. So what we're going to do now is we're going to actually do some of those tests algebraically. And again, I said this is the best way to figure out if something is even or odd. When you look at a picture, it might look like it's even or it might look like it's odd, but if it's just the tiniest bit off, if the equation, if it's just over to the left a little bit, it's not going to be an even function. So again, your best bet is to go algebraically. So let's check it out. Let's see what happens. Okay. Excuse me. So we want to determine whether the following functions are even or odd. I'm not going to draw these graphs right now. We're not going to worry about that. But I do want to determine if they're even or odd. So again, for all of these, the test is to plug in negative x. So I'm going to take negative x as my input, and I'm just going to plug it in. All right. First step, rewrite the function with negative x inputted. Okay. Now we can go to work. Well, we know that when we raise a negative to an even exponent, it just becomes positive, okay? Or hopefully we know that. We should know that. Negative x to the fourth is just x to the fourth. And negative x squared is just x squared. And positive 5, nothing happens, okay? So this is our f of negative x function. And what do we notice when we take a look at all of the pieces? Okay, this is the same. Okay, this is our hint. We plugged in negative x, we got the exact same function. Therefore, okay, that's the symbol for therefore. I might be using that. You might know it from geometry. Therefore, our function f of x is even. Okay? Therefore, f of x is even. Again, what did I do? I just went through each piece and I noticed same. Let's try another. Again, test doesn't change. I'm plugging in negative x everywhere. So negative x, then cubed, plus negative x, minus 1. Okay. Let's see what happens. All right. Again, hopefully we understand this. When we have a negative and we raise it to the third power, well then that's going to keep the same sign. So this we know will be negative x cubed plus minus x is minus x, and here we have a minus 1. So again, we're done with our f of negative x function. And actually I should box these just so you guys kind of see what I'm talking about and checking with. Alright. So there are the functions. Now let's take a look. Alright. X cubed, negative x cubed. Opposite, good. Positive x, negative x, opposite. Negative 1, same. Alright? Because these two functions are not completely the same, or not completely opposite of each other, what we are going to say is that f of x is neither even or odd. Okay? If you wanted to just write the word neither, I would accept that. I'm just trying to be thorough, okay? So again, because these are not completely the same or completely opposite, they're neither or neither. All right, let's move on to the last one. This one's going to be a little tricky because we have a fraction. We're still doing the same exact thing though. F of negative x. So what happens? All right, so 5 times negative x all over negative x squared minus 7. All right, plug in correctly and simplify. So this top becomes negative 5x. Negative x squared, hopefully we agree, is just positive x squared minus 7. Now, a suggestion. When you have fractions, especially when you have a negative in the numerator, I almost want you to factor out a negative or factor out a negative 1. And the reason I want to do that is because that's going to hopefully help us see a little better what's going on. So remember, I'm just going to take out a negative 1 from the numerator. All right, I have a negative there, so I'm going to take out a negative. And then what am I left with? Well, in the numerator, because that's what I took the negative out of, I'm left with 5x. And the denominator, nothing. It's all good, right? I didn't take anything out of the denominator. I actually can't take anything out of the denominator. So, I have something like this. Now, let's take a look at what we have. Ooh. Oh, and actually, let me rewrite this. Sorry. F of negative x equals that. Okay. So I have 5x over x squared minus 7. Amazing. I have another 5x over x squared minus 7. However, this one's negative. So what are we saying? I'm going to say that this function is the complete opposite of my new function, which means what? What am I going to write here? Hopefully you guys said it already. F of x is odd. And again, why? Because this is negative, this is positive. These are the complete opposites of each other. So we have an odd function. All right, so that's a little taste of even, odd, or neither. Of course, we'll be practicing it later. We're going to move on to a different concept now, increasing, decreasing, and constant functions. Okay, so hopefully we have an idea of what these words mean, increasing, decreasing, constant. But how does it work with a graph? Well, the thing you have to remember, and the thing that's super important, you always have to go, like you're reading a book in English, from left to right. Okay, super important. This doesn't work if you switch it up and you try to go right to left. All right, so from left to right, we're talking about when is our graph going up, when is our graph going down, or when is our graph kind of staying the same or staying constant. So if a function is increasing between x1 and x2, or x2, that's happening if the graph is going up. Pretty easy, right? Not too bad. So what do we notice here? I would say my graph is definitely going up here, and then it's down and okay, so that's the only place where my graph is going up, which means now I have to, using interval notation, I have to describe that section of the graph. All right, so we know that we're going left forever, which means I'm going to start at negative infinity, and then what's happening? I'm going all the way here, 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 here. Okay, I have an x value of 5, so I stop at 5, and then I close my bracket. Again, because I have a closed circle here, or an actual point at 5, 10, I'm going to use a closed bracket. There's some debate on that. We're going to go with closed brackets for this section, okay? All right, so now, if we're talking about decreasing, well, if increasing is going up, then hopefully we know graph is going down, okay? Not too bad. So when we take a look, I'm going to highlight, my graph is definitely going down here and here. All right, I need to describe those sections of the graph, and remember, I'm worrying about x values. So this is almost like domain. I care about the x values, and I'm going to write that using interval notation. So I start here at 5, right? This is going up, 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 up. I don't care about it yet. or at least for this question I don't. I start at 5, and then I go to 8. Is that it? No. I have a whole other section that I have to describe. So I union it with, and this one's picking up at 13, and it's going to an x value of 16, and I close. Alright? Now, I'm pretty sure we can all do the next section on our own, but let's just do it anyway, okay? We know function is constant between x1 and x2 if graph is staying the same. Okay? So right here, my graph is not going up or down. It's just staying the same y value. So I described that section. Well, my x values is not here, not here. Okay, right here. It starts at 8, and it goes to 13. One thing you'll notice when we do these problems, if you look at all three and kind of compare them, you basically listed the domain here. Every single section is listed somewhere. It's either increasing, decreasing, or constant. So that is one thing that you can check to kind of help out. Okay, so to write the intervals of increasing, decreasing, constant, really we're just stating the domain of the section. Okay? Stating the domain of that section. So, as we move on to our next step here, we now need to graph. Okay? So what we're going to do, we're going to take out our calculators, and we're going to plug this equation into y equals. Alright, when we do that, let's see here. I get x to the 4th minus 7x squared plus 6x. Okay? Alright, so I plug that in. I hit graph. Oh, my window's terrible. Let's change that right now. Negative 10, 10, negative 10, 10. Alright, let's see what happens here. Okay, do I have a stat plot on? I do. Let's turn that off. Try this again. Sorry about that, guys. Alright, so I'm not quite there yet. I need to fix this a little more. So let's see. Let's change my window. I know I have to add a little extra to my y minimum. So let's check negative 20. Still no. Let's check negative 30. Now I know I'm going to want to change this y scale, just so it's not so crazy looking. And it looked like I could also change my x-min and x-max at the same time. Like it was too wide, so I wanted to narrow it in a little bit. So I hit graph. Okay, here we go. Much better. Alright, so we're going to sketch this, right? We want to sketch this. I see I have some intercepts at 1, 2, so negative 3 is an intercept. 0, 0 is an intercept, it looks like. 1, 1 looks like an 1, 0 looks like an intercept. Okay, so it looks like I have all these intercepts. Now, what I care about is kind of drawing this shape. It doesn't have to be perfect, but you want to get it pretty close. Alright, so something like that. And the reason is because now I can kind of see where I'm increasing and decreasing. Okay, increasing and decreasing. So what I'm going to do is, in pink, I'm going to highlight increasing. So right here, I'm from left to right, I'm definitely decreasing. Ooh, at this minimum, I change from decreasing to increasing. And then at this maximum, local maximum, I change from increasing to decreasing. And then at this minimum, I change from decreasing to increasing. Okay, so we are going to need what? After I highlight these, or kind of sketch this in a little bit. Okay, there's one, or there's my pink for increasing. I can go yellow for decreasing. Something like that. What words did I use, though? What did I say? We need the local min and maxes. Alright, so you guys are going to have to remember how to do that on the calculator. So, second, calc. I'm going to get my minimum first. I'm going to go to the left. I'm going to go to the right. I'm going to guess. And I get this point to be negative 2.06, comma, negative 24.06. So that's good. Now, I have a maximum, so I need to use this calculate, and then I'm going to go maximum here. Now, here's one thing that I want to kind of teach you guys. Instead of like clicking over left, right, whatever, I can just use numbers. I know that I'm looking for my maximum. It's between 0 and 1. So for the left bound, I can just type in a 0 and hit enter, and it sets that point for me. I don't have to just scroll over anymore. It's just it might be simpler sometimes. Right bound, I know I was going to say 1, and then I guess you still want to kind of guess using the cursor. So here I have a point at 0.46, comma 1.32. Sorry, that is a 3. And then lastly, my last minimum, I'm going to say is between 2. Oh, my bad, guys. Let me go back. Sorry, calculate. My minimum is between 1 and 2. So I guess, and it gives me 1.60, comma, negative 1.77. All right, good. So we have our min, our max. What we need to now do is we need to list our intervals. So increasing and decreasing. So again, remember, our increasing, we went with pink. We went with the color pink. So that means I have to describe from this section to this section, and then again from this section to this section. What did we do here? Intervals, it helps its domain, okay? It's x values. I care about the x, so I don't care about the y values right now. I just care about the x's, which means that I want to start here at an x value of negative 2.06, and I go all the way here to 0.46. And then remember, I'm not done, right? I have to pick up this last section. So I union it with, well, this starts at 1.60, and it goes on and forever towards positive infinity. Decreasing, same idea, different sections. Here I know that I'm starting at negative infinity, right? This goes on forever. So I'm going to start at negative infinity, and I'm going to go all the way to negative 2.06. And then what happens? I stop at negative 2.06. I jump to my next section, my next yellow section. So 0.46, comma 1.60. All right? And we had 4 sections. We have 4 sections being described, which is a good thing to check. All right, I know this one's running a little long. We're going to finish up. I'm going to try and go quick on this last one, and we will be done. Okay, excuse me. So, to finish up here, we have a graph. Let's kind of see what's going on here. All right, so at what values does f have a local maximum? Well, not here. I only see 1, right? This is the only place on my graph that is a local maximum. So, at what values does f have a local maximum? That is just my x value, right? F is kind of like y. So I just want to know that x equals 1 is where I would have my local maximum. What is the local maxima? Well, now I want the point. I want 1, comma 2. See the difference? At what values does f have a local maximum? I want to know at what value of x. All right? Now, at what values does f have a local minimum? Well, now I'm going to say I have 1 at negative 1, and I have another one at 3. So, what are the local minima? Well, in this case now, I know my x value is negative 1, and that leads to a point of negative 1, 1. And then here I was at 3, 0. So now, to finish up, I'm going to list the intervals. I see no constants. I only see increasing, decreasing, so I'm just going to kind of section those off, right? I can go increasing, increasing. I can go decreasing, decreasing. And again, I just have to now list that. So, increasing, decreasing. Well, let's take a look. From increasing, the increasing standpoint, I want to know what x values lead to my function increasing. So I start here, right? I'm going down, 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 down. All right, right here at an x value of negative 1 is where I start to increase, and I increase all the way to positive 1. But then I start to decrease, right? So I have to skip this section, and then it picks up again. It starts to increase again at x equals 3. And then it increases forever. Decreasing, pretty much looking at the opposite sections, right? It starts out decreasing. So it starts from negative infinity, and it decreases all the way to negative 1. And then it increases, and then it picks up again right here at positive 1. It starts decreasing again, and it decreases until x equals 3. So 1 to 3. All right, so this is a good first taste of even, odd, neither, as well as increasing, decreasing, and constant functions. Of course, we'll practice. Make sure to ask me questions if you are having trouble with any of this. Peace.